Hello seekers, welcome to my channel Science Seekers. Today we are going to discuss another interesting topic, two-body harmonic oscillator. In two-body harmonic oscillator, let's consider two masses of M1 and M2 connected by a massless of spring of force constant K. There are two masses M1 and M2 connected to a spring that is K. If the masses are slightly displaced from the equilibrium in opposite direction, the spring extend or contrast and exert a linear restoring or elastic force on both of the masses. These masses are released about their equilibrium position. Their center of mass remains rest. Center of mass remains rest. Such a system is called the two-body oscillator. Here are the two forces F1 and F2. That is the restoring force. Let x1 and x2 are the distance between M1 and M2 and O is the origin of an initial frame of reference at the instant during the oscillation. Here let L be the equilibrium length of the spring and x the instantaneous change in the length. Then in this figure x2 minus x1 equal to L plus of x. x2 minus x1 equal to L plus of x. That is equation 1. If x is positive, the spring is stretched, and if f is negative, the spring is compressed. So the restoring force is exerted by the spring on each mass of the magnitude, that is kx. So for the mass m1, the restoring force will be f1 equal to kx, and for the mass m2, the restoring force f2 equal to minus kx. We know that from Newton's second law, F equal to ma. Newton's second law, F equal to ma. So F1 equal to kx and m1 d square x1 by dt square. The next force F2, that is minus kx. So is equal to m2 into d square x2 by dt square. Multiply the first equation in m2 and the second equation by m1. Then subtract the first from the second, and the result will be m1 m2 whole into d square x2 by dt square minus d square x1 by dt square equal to minus k whole into m1 plus m2 into x. So d square x2 by dt square minus d square x1 by dt square is equal to minus k whole into m1 plus m2 by m1 m2 whole into x. So d square by dt square whole into x2 minus x1 equal to minus k whole into m1 plus m2 by m1 m2 into x. But we know that x2 minus x1 equal to x plus L in the first equation. Here we put this value, we get d square by dt square whole into x plus L equal to minus k whole into m1 plus m2 into x. Because L is the constant, so d square L by dt square will be also 0. Then the last equation is reduced to d square x by dt square is equal to minus k whole into m1 plus m2 divided by m1 m2 whole into x. That is the equation 2. The quantity m1 m2 divided by m1 plus m2 is defined the reduced mass. So in the system it denoted by mu, that is mu equal to m1 m2 divided by m1 plus m2. So the above equation 2 will be reduced to d square x by dt square is equal to minus k by mu into x. D square x by dt square is equal to minus omega square of x. That implies d square x by dt square plus omega square x equal to 0. That is the differential equation of two-body harmonic oscillator. The solution of the differential equation will be x equal to a sin omega t plus phi. The solution of the differential equation of the two-body harmonic oscillator is similar to the simple harmonic motion or simple harmonic oscillation. So where is a and phi are the constant, and the time period and the frequency will be, time period formula is t equal to 2 pi by omega equal to 2 pi root under mu by k, and frequency f equal to 1 by t. Frequency f equal to 1 by t, that is 1 by 2 pi root under k by mu. That is the frequency and that is the time period of the two-body harmonic oscillator. That is for today's seekers. In further classes, we will discuss about another interesting topic. I hope you all understand the class. For any queries, do comment. If you guys like the video, just like, share and subscribe for more interesting topics in future. See you all in the next class. Thank you guys.